studies that follow a good scientific protocol for the study of fatalities. There are some studies that have been conducted that we didn't include because the way the data were collected, they didn't follow standard protocol. So these are fairly standard protocol studies. So in northeastern studies, the range is slightly less than 6 fatalities per megawatt per study period, down to slightly over 1 bird, 1 fatality per megawatt per study period. This happens to be in Maple Ridge, New York. This one happens to be in Noble, Clinton, New York. So again, there's no real pattern as far as states are concerned. It's more related to habitat and abundance of birds, probably. So another issue that has gotten a lot of interest in recent years are bat mortality. The studies that we were involved in, and most all the consulting scientists have been working on this issue for a long time, we were really focused on birds from the start. We found bat carcasses in almost every facility we studied, and so the concern about bat fatalities became much more important in recent years. So there are a few things that we know about bat fatalities. They've been reported at all wind farms investigated across a wide range of habitats. Predicting bat fatalities at wind facilities remains extremely difficult. And the problem is it's very hard to estimate how many bats there are in the environment. We have a much better idea of how many birds exist than we do bats. We just know that there are lots of bats. Common results from bat studies, the impacts are unequal across species. I'll say a little bit more about that in a moment. Most mortality occurs in late summer. And I have a slide that illustrates that. If you remember, I said bird fatalities kind of concentrate in the spring and the fall. Well, bats, for some reason, concentrate in the fall. Mortality appears highest along forest ridge lines, but there have been a few other studies recently that indicate fatalities can be much higher in areas other than forest ridge lines. So it's not unique to forest ridge lines. It's as unique as we thought it was at first. So the mortality of spring and summer resident bats is not as high as late summer and fall. So it appears that most of the fatalities are really heavily weighted toward bats that migrate over long distances, and that includes the tree bats such as the hoary bat, the eastern red bat. The fatalities for bats are much more common for those types of bats rather than the Myotis species, the common bat you see in urban areas that live in caves and houses and those sorts of things. So to illustrate that, in the east, for example, the eastern red bat makes up almost half the fatalities at eastern facilities. If you look at the rest of the country, this is the hoary bat that's the most common species. Regardless of where you are and what kind of habitat, the hoary bat is the most common species found in these fatalities. In the east, the hoary is also fairly common. So if you combine the eastern red bat, the hoary bat, and the eastern red bat, and this is the little brown bat, you have most of the species that occur in the east. And these, I've said nothing about the relative abundance of these species. We don't know for sure how many of any of these species exist, but more than likely, the eastern pipistrelle, for example, this bat here, is much more common than the hoary bat, and probably the eastern red bat. Bat fatalities in the west are fairly low. And the further east you go, the higher the fatality rates are. The average bat fatalities is 6.3, so that's slightly more than twice as many bats per megawatt per study period than birds. The Buffalo Mountain bed for bats is the highest fatality rate that's been detected so far. But interestingly enough, that larger facility at Buffalo Mountain still has the highest, one of the highest fatality rates in the country. The pattern of bat fatalities is pretty obvious here. That we showed a bump in the fatality rates for birds in the spring, but you don't see anything like that in the bats. What you see are very high fatality rates in the fall, presumably during the fall migration period. And that's consistent with, regardless of which region you're in, this would be the eastern region here. Okay, the studies that we base these on are the same studies for the most part as the bird fatality estimates for both studies. So in the northeast of the U.S., Mountaineer, the site in West Virginia, which is actually the site that generated the initial major concern over bat fatalities, Mountaineer has the highest bat fatality rate of any facility that we study or the data are public on in the eastern part of the country. So when this one raised a lot of concern over bats, we didn't know whether this was the lowest that we're going to find or the highest we're going to find, or whether it was an average or representative. But so far, it looks like it's one of the highest, the site that has killed the most bats per megawatt per year. Quickly, the third major category of impacts or loss of habitat. That is either direct habitat loss, where the vegetation is removed or the landscape is changed to the point where the habitat no longer occurs. That'd be the turbine pad, for example. And indirect loss due to disturbance. There are some species that avoid areas that have higher activity. Some concern that some species may avoid wind turbines simply because they're large rotating things. So the direct impacts are relatively small. This is a wind facility in Wyoming, one of the first large utility grade facilities built in the country. These numbers here were taken from planning documents. No one has actually gone out and measured the direct habitat loss because it appears to be pretty much what people's predicted. So nobody's actually gone out and measured the size of these little white polygons here, the pads and the rows. But based on the prediction of impacts, the temporary construction impacts are, that's the largest direct loss, and that's up to 3 acres. That's going to vary depending on the topography and the vegetation. Clearly, if you build a facility in a location like this, the disturbance to the terrain and the habitat's going to be much less than it's going to be if you're building it on a mountain ridge in California or New York or Virginia. Permanent operations run about 3/4 to an acre per turbine. That includes the pad and the rows. The permanent impacts really depend on reclamation success. If you can successfully reclaim an area fairly quickly, then impacts tend to be short term. If reclamation is very difficult in some desert areas in the west and southwest, the reclamation will be very slow, and so the impacts can last much longer. The BLM in a EIS estimated that 5–10% of the site in the west of these on public lands would be permanently changed. The species that are that raise the most concern about habitat loss due to displacement are grassland birds. And several turbine studies have shown small scale effects, a few hundred meters, up to a few hundred meters. A bigger concern are prairie grouse like greater prairie chicken, lesser prairie chicken, sage grouse. Those species tend to live in more open environments, so there's a concern that wind turbines might cause them to avoid turbines up to well, there's been some pretty wild estimates on how far away a sage grouse will actually nest from a turbine without a lot of empirical evidence, but some people are concerned that there could be several miles. There are studies currently underway to determine what that distance actually is. Raptors, there have been several studies of nesting behavior, and so far there haven't been any significant impacts to nesting raptors that we've been able to, that have been documented. Again, big game, there have been a few studies, there are currently a couple of studies, telemetry studies ongoing to determine if there are major effects from big game. There's a big concern in the West, for example, that wind facilities built on the winter range might cause animals to abandon the winter range. No empirical evidence, and we're looking at that. Hoofing cranes, the T&E species that right now is probably the biggest concern in the Midwest. There's concern that, actually the bigger concern is loss of habitat. Fish and Wildlife Service is very concerned that turbines that are, or wind facilities that are built in habitat that the cranes depend on as they're migrating from breeding to winter ranges could be lost because of behavioral avoidance. So I'll summarize the fatalities for birds. With the possible exception of the Altamont Pass wind resource area, avian fatalities appear to be risks to individual birds, but not to populations. I hope that makes sense. There is a risk for fatalities in individual birds, but so far there's been no evidence that those fatalities have had any effect on avian populations. The preliminary information suggests that there are a number of factors that probably influence fatalities. Probably the one that's the most evident, particularly with raptors, is avian abundance. There are species behaviors. I mentioned the ravens and vultures are less likely to be killed, it appears, and we believe that's due to behavior. The technology at the Altamont Pass wind resource area was older technology, lots of places for birds to perch, and the modern facilities have pretty much eliminated most perching sites at the facilities. The monopoles for the support structure have very few roosting or places for birds, and most of the electrical service within a facility is underground. So a lot of things have changed since Altamont. And there are some evidence that landscape issues can increase the occurrence of raptors in the zone of risk or the rotorship area. For birds, there haven't been enough studies of deterrent measures to really know whether they're going to work for birds. I'm not very optimistic because I've been involved in deterrent studies in the past.